Hi, my name is Dan Benoit.
And I'm Xiaolin Chen. Welcome to this installment of our video blog, Casual is the New Formal.
In this video, we'll discuss how to bring your design up in a formal tool and properly initialize it. Compiling RTL design code is usually not a problem if it follows synthesis coding guidelines. But sometimes we do see problems with code written specifically for simulation-based verification.
That's right. In simulation environment, there are usually some verification code not intended for implementation. For example, memory models, your clock generators, or diagnostic monitors. They are not compatible with either synthesis or formal tool. So you can either choose to use compile directives to carve out the portion of the incompatible code, or you can choose to black box the entire module so they can be excluded from formal build altogether.
That's true. Black boxing is a technique to exclude some code from formal analysis, usually at the module or instance level. VC Formal will automatically black box any modules missing from the compile list. Signals that are inputs to black box become outputs of the design, and black box outputs become new design inputs. If the behavior of the black box code is important to the properties we need to check, we may need to add constraints to these new design inputs.
That's a very good point, Dan. For example, memory or FIFO models are often not synthesizable. You may need to develop alternative formal compatible models so they can be used for formal analysis.
Okay, so once we have the design compiling cleanly, it's time to think about clocks and resets. Unless the design is purely combinational, it's critical to specify the clocks correctly. If the design has only one clock, this is trivial. But how can we set up a multi-clock design?
For formal verification setups, all of the clocks must be synchronized, or at least they are derived from a common master clock. This master clock, however, is usually automatically generated by the tool. So what you should avoid doing is specify multiple clocks with periods that are not simple multiples of one another, because the tool has to generate a master clock that is extremely high frequency in order to synchronize all of the clocks. Then you may see formal performance get compromised. Right, Dan?
That's right. If your design has truly asynchronous clocks and requires cross-domain synchronizers to avoid metastability issues, we recommend using a dedicated CDC tool. For formal property checking, you may need to create a synchronous approximation of the clocks to check properties such as handshakes that span across the clock domains.
Yeah, that's very good advice, Dan. So now, what about reset?
The general principle for reset is to do the minimum necessary to bring the design into a valid state. Some designs don't require any reset, for example, combinational circuits or pure pipelines. But many other designs can be initialized by holding a reset signal active for a single clock cycle. If the reset you specify is missing or inadequate, you may see false assertion failures, and these failures can be traced to the registers or memories that are starting up in illegal states.
That's right. VC Formal offers the capability to specify resets from a tool script. In some cases, it might be easier to import an initial state from simulation. Formal tools can usually extract the initial state from a VCD or FSDB file. But you should be really careful that you understand that impact of the initial state that your formal tool is using. Because if your initial state is not general enough, then you might see false property proofs. In other words, you have over-constrained your initial startup state, and some bugs may escape because of that.
Thanks, Xiaolin. In future videos, we'll talk more about detecting and avoiding over-constraint. But until then, thanks for watching. Casual is the new formal.
Bye.